Hello everyone, my name is Ian McLaughlin, and I have a PhD in neuroscience, and I'd like to talk about an article that explores a predisposition that I think we all have. And frankly, I think it's one of the things that was, likely a massive advantage in early Homo sapien evolution that's turned into a pretty substantial vulnerability, in-group bias. So this is one of those concepts that's sort of intuitive, right, but also pretty complicated, and has a pretty substantial history behind it. And so at its simplest level, it's this tendency that we all seem to have, where we tend to favor the well-being of individuals to whom we are close over those to whom we aren't. Pretty simple, right? And there are some fairly simple explanations for why it is that we tend to care about some humans more than others. There's a fairly famous quote from the biologist J.B.S. Haldane, which goes something like, quote, "I will gladly sacrifice my life for 2 brothers or 8 cousins." The concept being, the more genes that you share with someone, the more likely you are to instinctively care about their well-being. And, to be totally clear, if you save the lives of 2 siblings who share approximately half of your genetic information each, right, you save the equivalent of all of your genes with, the 2 siblings saved by giving your life to save both of them. Similar concept with the 8 cousins, right? Each has about 12.5% of your genetic material, and so saving 8 of them would equate to all of you. And this is obviously an absolute oversimplification. That's really not how genes work when it comes to siblings and reproduction and so on. It's not perfectly mathematical that way. It's messy, as biology always is, but it conveys the fundamental point that the genes that we all share seem to play a role in how much we'll tend to preoccupy ourselves with others' well-being. And so this is J.B.S. Haldane, by the way. Pretty classic. He's an interesting character in the history of science. An example of when science and politics can kind of collide. However, irrespective of all that, the fundamental point he made is useful. There seems to be a reason that you're very likely to care more about the well-being of your brother, your sister, your mother or father than your unrelated neighbor, right? However, in-group isn't limited to people who are, most closely genetically related to you, though that's absolutely a major source of those in-group affiliations. But even beyond simple genetics, there are other factors that can make you feel instinctively driven to sympathize with someone you've never met over someone else you've never met, right? And so for an example, you might be more likely to care more about your next-door neighbor than somebody 30 miles away, right? And then even then you might be predisposed to caring about that person 30 miles away more than someone who lives 300 miles away. So for example, to give you a sense of those distances, that's almost precisely the distance between Philadelphia and Boston, which, to people outside of the United States probably sounds like a meaningless difference, right? But these are 2 rather different cities in 2 rather different states, despite both sharing a sort of rich history in American history. So, they speak the same languages, theoretically. There are 2 pretty clearly different accents, right? And the whole sports fandom situation is just bananas in both cities. Both are notorious. But in any case, it wouldn't be deranged to suspect that 2 people in Philadelphia, as diverse a city as this is, that 2 people from the same city would tend to favor each other over someone from Boston without ever having met them. And so that's sort of what we're talking about here when it comes to in-group versus out-group, right? A tendency to favor certain people over others, contingent upon some kind of shared feature. And of course, cults are a particularly interesting manifestation of that tendency that we have, being exploited to cultivate a kind of hierarchy, right? Based on the drive that we all have to be part of some kind of tribe, some kind of group, to belong, right? And at the most basic level, that's sort of what we're talking about, is this tendency towards pro-social behavior versus antisocial, right? And we preferentially extend pro-social behavior to certain individuals within our groups over those of other groups. And so you probably don't have to strain your noodle too much to think of categories that can be used to define in-group versus out-group dynamics: nationality, religion, race, but even things like fandoms, musical genres, even exercise communities like Peloton, for example. There are examples of these dynamics throughout our daily lives all over the place, and one can be part of several in-groups. And so the issue is that this predisposition towards being, driven to join some kind of in-group seems to result in an empathy gap when it comes to out-group members. So in other words, we'll have a tendency to not only experience a heightened level of empathy extended towards members of our in-groups, but we'll also tend to extend the opposite towards out-group members. Just pragmatically speaking, this manifests as a predisposition to pay a greater personal cost to intervene in the suffering of in-group members compared to out-group members. And so, in other words, you're willing to sacrifice more to prevent the people to whom you are closest from suffering or having negative experiences. And so, intuitive as this all may be, it's a kind of interesting predisposition that we all have as primates. And I use that term primates deliberately. So it turns out that we, Homo sapiens, aren't the only animals in town who exhibit this kind of in-group, out-group social predisposition. And so in fact, basically any animal that you can name does as well. And so certain other primates like chimpanzees and bonobos, I never miss an excuse to look at pictures of other primates, but all the way down to the noble mouse. We all exhibit this tendency to, extend extra empathy to certain members of our own species over other members of, other species. And that is true also, we'll tend to, extend that same thing to members of our own species against, other members of our own species. So, just for example, just like us, right? Rodents will experience stress and fear when they see other rodents having negative experiences, and they'll extend comforting behaviors, right, towards rodents that have just undergone some kind of stressor, right? They'll exhibit behaviors that are beneficial to other rodents beyond solely their own personal benefit. And these kind of comforting behaviors can be manifested in all kinds of ways. And so, pretty complex social interactions, right? They can detect the suffering of another member of their species, and they respond with a specific behavioral repertoire to comfort them. And so, it can be tough for some humans to exhibit that kind of selfless behavior, right? I'm kind of kidding, but basically any species that exhibits social behavior will have these tendencies. We all share a common ancestor at some point, right? Okay, so we all tend to exhibit this tendency, right? But why does it happen? How does it happen? What part of our biology drives us to exhibit this bias? And that's what it is. It's a bias. Because, that's what this team set out to do, right? To figure out what part of the brain drives this predisposition. And there's the study. So, by the way, any astute neuroscience observers might recognize one or more of the names in this list of scientists, but likely, a couple names, but would likely catch that Carl Dieserath is included in the authors. Kind of interesting. By the way, I have a funny story about Carl Dieserath. So, for anybody who's unfamiliar, Dieserath was one of the two main scientists who really introduced the technique of optogenetics into neuroscience, a pretty revolutionary at this point technique where you can control the activities of specific neurons in the brain. I was at the Society for Neuroscience conference. I was presenting my research, and it's a gigantic, tens of thousands of scientists all converge on one city and basically take it over like pirates. And there's a lot of after-conference pirate-like behavior with drinking and loud conversations and arguments. But anyway, so I'm looking at this poster that's very interesting. This other scientist was studying the same circuit that I studied, and I'm sort of just going back and forth with her techniques and the sort of stuff that didn't land on the poster, right? The kind of interesting stuff. And we're having this long conversation, very lively, and the whole conference room was sort of emptying out. Right? And so there's just a couple, several dozen people in this giant conference room. This was in Washington, D.C. So I'm having this conversation, and I notice her eyes sort of flicker behind me, and I'm like, who's that? Almost directly behind me was Carl Dieserath listening to our conversation the whole time. I'm glad I didn't know he was there because he's a pretty successful scientist. But anyway, so, this is a pretty widely distributed collaboration here. You can see a lot of authors' names, and people, scientists from Tel Aviv to Toronto to Stanford and Berkeley. Pretty cool, right? It's always fun to see those kinds of broad collaborations. And so this group was working with rodents, trying to figure out what was going on in the brain when they intervened to free a trapped in-group member, the rodents, trapped in-group rodent, versus a trapped out-group rodent, right? And so these experiments revolve around something called the helping behavior test, which is exactly what it sounds like, right? Seeing when a rodent will release another rodent from some kind of restraint, right? And generally speaking, rats will tend to preferentially release members of their in-group while not really doing so, at least as readily, for out-group members, or at all. And so as Inbal Ben Ami Bartal, probably mispronouncing that name, I apologize, but they are faculty at Tel Aviv University. This is what they say, quote, "Humans, as well as many other creatures, are biased towards helping other members of their social in-groups over individuals they view as outsiders, and this can have a negative impact in diverse societies where different groups need to cooperate in order to thrive." And then later they say, quote, "Understanding the brain mechanisms underlying these biases is essential to finding ways to eliminate them." Okay, so that's why this group is working with rats, right? Given that they exhibit the same kind of predisposition towards helping in-group rats over out-group rats, we might be able to get a sense of what it is in our brains that causes us to do the same. And while their brains are obviously significantly smaller than ours, right, rat brains relative to human brains, they do have essentially all the same anatomical structures that we have, but just smaller and simpler. And to be clear, that's actually not an entirely uncontroversial statement to make. There are definitely some neuroscientists who'd argue that rodents don't actually have a prefrontal cortex. That's as just one example. But when it comes to this study, the structures that they were studying, that's largely inconsequential. Okay, so we're basically on the hunt for which parts of the brain drive that predisposition that we, like essentially all other animals, have for treating certain other members of our species better than others within this group, right? And so there's one thing that is pretty central to how they did their experiments. And that is this behavioral technique, the helping behavior test, right? So pretty much everything revolves around putting rodents in that situation and seeing what's going on in their brain. And so, this is a behavioral test for rodents that's devised to explore that tendency that we, like other animals, have, right? To be driven to help others with no obvious concern for a payoff. That's the sort of a very important component of this. So this is sort of like when people saved beached dolphins. And so this picture is from a pretty wild video from 2012, which is like ages ago, almost 10 years ago. Jeez. And you can find this video. I have a link in the description below, where basically a whole group of dolphins, an entire pod of dolphins, I guess, that ended up getting beached, like all at the same time. And something like 30 dolphins getting beached. Totally bananas. And so yeah, link down below if you want to check out that video. But anyways, it is sort of similar to that. But when it comes to this study, what we're really talking about are conspecific interventions, right? Which basically refers to when an animal, including humans, intervenes on behalf of a member of its own species. And when it comes to this helping behavior test, rodents have been shown to help other rodents who are in a restrainer, right? Despite, with no expectation of reward or even any familiarity with the restrained rodent. They never met before, but the rodent will intervene if they're in the same in-group. And so, that was the way that they were exploring this whole tendency, right? Now, there are some potentially spicy interpretations of this study involving how it is that in-group and out-groups were defined in this study. But at the simplest level, they were working with different strains of rats that have different fur coloration, okay? And so here's what they found. So first of all, rats, just like us, exhibit a bias towards helping, members of their own in-group over out-groups. Okay. And they confirmed that, right? And they found that there were certain brain regions that corresponded to this behavioral predisposition. But some brain regions were only associated with when rats intervened on behalf of their own strain over the other strain, their in-group over the out-group. And so in case you're interested, when it came to intervening, no matter what the strain was, right, where a rat would just help out another rat, didn't matter if they were part of their in-group or out-group, they found activity in the orbitofrontal, anterior cingulate, and insular cortices. Okay, so those are 3 different brain regions. And so, if a rat was helping a buddy out, irrespective of whether they were the same strain, didn't matter, those brain regions exhibited increased activity. So you're helping, activity in those brain regions. Pretty cool. Okay. However, the interesting aspect of this study is which brain regions were only active when the rats intervened only on behalf of members of their own strain, of their in-group. So, once again, it's not super critical to know precisely which brain regions were involved, right? But if anybody's interested, they honed in on the medial orbitofrontal cortex, the prelimbic cortex, the lateral septum, brain region I studied, and the nucleus accumbens, another brain region I very much so studied. Those are the brain regions that were especially associated with, instances when, the little rodents intervened on behalf of members of their own in-group. Okay, and so in particular, the nucleus accumbens was central to when rats intervened on behalf of in-group members. Okay, so, anyone who does any behavioral, addiction, or even just mood-related research is very, very intimately familiar with the nucleus accumbens. And so the nucleus accumbens, one of my favorite brain regions, you can see right there, is a part of your brain that's basically like a central dopamine depot. Okay, so do you see that part that's labeled ventral tegmental area towards the bottom there? It's oftentimes just initialized to VTA. So that's where a whole ton of your brain's dopamine is created. The neurons in that part of the brain crank out dopamine and send it to a couple brain regions. But when it comes to the expectation that something good is about to happen, the expectation of reward, that specific connection between the VTA, the ventral tegmental area, and the nucleus accumbens is the main character, right? The central driving signal in the behaviors that are driven by the expectation of something good happening. So that is actually just one component of what this circuit in the brain does. It really is associated with salience, like whether or not something is relevant. And by relevant, is it going to generate good things for me, right? Sort of kind of a similar way to frame it. But then also it's error correction, right? Because if you do something and you expect something good to happen and it happens, okay, great, you were correct. But if you do something and you expect something good to happen and it doesn't happen, that feels bad, right? You're expecting something good and you didn't get it. And that dopamine signal is the sort of central character in that whole plot, right? Where, because it feels bad, that directly corresponds to a reduction in dopamine in that specific circuit, right? So it's fundamental to how we learn from our experiences. Okay, so and beyond that, like the reason that anyone studying things like addiction or mood are intimately familiar with this pathway is that basically any drug that people consume voluntarily, like for fun or whatever, cranks up the activity in this neuronal pathway between the ventral tegmental area and the nucleus accumbens. So any drug you can name, cocaine, cannabis, amphetamine, and heroin, right? But also alcohol, nicotine, and even caffeine, right? All influence activity in this pathway. That's why people are driven so voraciously consume those drugs, particularly under certain circumstances. And so that's part of the reason that understanding how it is that these substances influence the brain can be helpful to understand how it is that human consciousness works, right? These substances that have zero nutritional value, right, don't taste particularly good, but humans voluntarily consume them. And they consume them sometimes at, dangerous or even fatal levels. And so this group found that when rats were approaching their little buddies who were trapped, who were members of their own in-group, activity in the nucleus accumbens, that part of the brain that receives dopamine signals, was quite a bit higher compared to when they were approaching some other random rat that had less in common with them, right? And quite a bit higher compared to when they'd come across just a random restrainer that didn't even have any other rat involved, right? So that's the green line, empty restrainer, and all of these curves are activity in that nucleus accumbens, the neurons in that brain region. The blue one is when a rat would approach some other random rat that wasn't part of their in-group, and then the red one you can see really peaks right when they detect that this other rat is a member of their in-group, spike in dopamine. Okay, so this specific brain region seemed to become active when rats came across other rats with whom they shared some kind of general feature, right? Members of the same strain. And so, by the way, they were working with an experimental method called Fibrophotometry, which is, I assume, why Carl G. Seurat is on this paper. And that was a technique, actually, that someone in the lab had just gotten off the ground when I had finished my work. It's really cool. It basically enables you to essentially observe changes in levels of activity in various parts of the brain, right? You can essentially see changes in activity. It's pretty cool. It's not super precise, but it's very, very useful, particularly when you're interested in like just a general region of the brain. Very, very small region of the brain, but as opposed to like specific neurons. But anyways, they didn't only have data that implicated the nucleus accumbens, right? They identified whole networks of brain regions that were associated with when the rodents interacted with other members of their in-group versus members of their out-group. And so you can sort of see that here. These are all those little nodes are brain regions, right? And so you can see, right, they have out-group response neuronal networks and then in-group, right? And they were distinct. And so it's sort of unsurprising, I guess, right? But also kind of provocative, right? That this pathway would be involved in this kind of behavior when, a rat or an animal is intervening to help another member of their species despite no obvious payoff. And so the scientists propose two interpretations of these data. First, that this constellation of brain regions is what underlies empathetic helping, okay? The drive to relieve another individual's suffering. That is just inherently rewarding to intervene to help another. That's their first interpretation. Another is that the rats, and by us, by extension us, will tend to intervene to help members of our in-groups because we're driven to create new social contacts that redound to our benefit in some way, right? You don't even know what the benefit is going to be, but it always helps to have a few favors in the bank, right? And so there are other potential interpretations of these experiments, right? It's not a perfect encapsulation of decision-making associated with in-group, out-group interactions. But these kinds of limitations are generally present in essentially all behavioral experiments. And so, regardless, this does sort of put how we think about empathy and selfless behavior into some informative context, right? And so as the lead scientist says, quote, "This research shows that the reward system has an important function in helping behavior. And if we want to increase the likelihood of pro-social behavior, we must reinforce a sense of belonging more than a sense of empathy." Interesting. As opposed to, belonging to an in-group, as opposed to it is just good to be empathetic, right? And so why do I find this research interesting? So apart from being sort of in the same category of research that I did in grad school, I have a feeling that this predisposition that we all have, right, to favor in-group members over out-group members as a function of some kind of largely arbitrary preference or, shared feature is something that's been exploited in many ways to motivate people to behave in ways that cause unnecessary suffering and that redounds to the benefit of people who are largely uninvolved, right, but are somehow benefiting, right? And so I'm not suggesting that there are no substantive differences between us, obviously, and I'm just soapboxing here, I know, but I think that at least sometimes those differences would be largely inconsequential were it not for certain entities that see an opportunity to harvest personal benefit, right, from the intense tension that people who see themselves as fighting against some kind of out-group experience, right? And so, it's totally innocuous and maybe even healthy in some cases, like when it comes to, sports rivalries or school rivalries or even just benign workplace rivalries that aren't vitriolic but sort of motivate people to try and quantify their performance and push the boundary, push the envelope, right? Nothing wrong with that in my mind. But in my mind, when it comes to things like political or religious or cultural affiliations, and some person or entity or whatever is painting the other as dangerous or threatening or whatever, universally, it doesn't matter. That whole out-group is dangerous. Sometimes, sometimes it's genuinely substantive, and I'll step down from my obnoxious soapbox imminently, but I suspect that at least in some cases, those distinctions are being exaggerated to achieve certain outcomes that have nothing to do with the best interests of the people who are actually expressing that in-group, out-group behavior. And so I'll leave you to imagine, what kinds of venues for this kind of friction I have, in mind, right? I'll leave you to imagine what instances of that happening might be. But I fundamentally think that, while this was almost certainly an adaptive feature of our consciousness during our early evolution, it's largely become a disadvantage at this point. So personally, I'm hoping that we will crawl out of this mire of misplaced in-group, out-group tension and try to make more of, sort of objectively rational choices. Obviously pretty unlikely given that there's literally a neural correlate for this predisposition, right? This. But one can hope, right? All right, that's what I have for you today. If you dig this kind of conversation about neuroscience and consciousness and so on, maybe you'll consider subscribing and liking and pressing all those helpful buttons. Otherwise, have a great week, and I will see you next time. Hey Scott, thanks for joining, and Watchmaker, thank you for joining. I'm not at all worried about passing on my genes, but I'm concerned with protecting my genes from damage. Just don't watch too frequently. That's a lesson that I learned too late in life, honestly. And so Scott also says, my cats seem to be able to tell when I'm not feeling well. They just don't care. Well, there was actually a study that came out. Well, I mean, I can't speak to your cats, obviously, but there was actually a study that came out that found that cats do, contrary to the sort of perception, they do form those kinds of pseudo-familial kinship bonds with humans. They just express them differently than dogs do. Because dogs very obviously do, right? And we do with dogs. And some people do with cats. Not particularly a cat person because I'm allergic to them, but yeah, they actually do. They are experiencing something. they're kind of quiet, right? They're a little reserved. They're aloof. So, and this guy says, Pirate Ian will discuss at length his editing of mRNA. Indeed. I did edit mRNA, well, I mean, indirectly, I guess, by using viruses. So, I mean, this work that they were doing, which figure was it? Was it this one? Nope. Yeah. This figure, this experiment, they did a bunch of experiments. This was just, I think, the sort of the nut of it. They had to use viruses to accomplish this, engineered viruses. And that's something that I did too. Give those rats the internet and they'll be hating each other by the end of the week. Yeah, exactly, right? Yeah, that's exactly what I was thinking. The only way people will unite is against an alien threat. Like, seriously, who was it? I think it was Ronald Reagan, who, like, former president of the United States, for anybody who's unfamiliar. I think quite literally was quoted as saying that. Anyways, all right, that's what I have for you today. Maybe you'll consider subscribing if you dig it. Otherwise, I will see you next week, and have a great week. See you, everybody.